Alright, in this video cast we'll start to look at section 11.2 called Intermolecular Forces. Before we can look at those though, we need to review a few things about things that stick together. What are some names of some stick-it-together forces that hold particles to particles? Well, the first one we learned about way back in chapter 2 were things called ionic bonds. Ionic bonds are usually between a metal and a nonmetal, and they're inside of that particle. They're inside of that molecule, if you want to call it that. And so it's the force that takes the K plus and the F minus and sticks them together. They're super strong. They have a really high numerical value. They have a bond enthalpy that's usually close to 1,000 kilojoules per mole. The second type that we've talked about but not gone in great detail about are ones called metallic bonds. And these are the bonds that hold metal atoms to metal atoms inside of a piece of iron or inside of a piece of copper or inside of a piece of zinc. And so these metal-metal bonds are also between the atoms inside of that metal. And then the third kind that we've talked about before are covalent bonds. Covalent bonds are ones that hold nonmetals together, and so they're the ones that hold H to Cl, both nonmetals, or H to H, and we can have varying degrees of the strength of those. There's unequal sharing of electrons. We have a polar covalent bond, and therefore it's a little bit stronger. If we have equal sharing, we have a nonpolar covalent bond, and it would be equally shared and maybe be a little bit weaker. But these, once again, are bond enthalpies or bond energies that would be a little bit less than something like an ionic bonded substance. Anyway, all of these types are called intramolecular forces. Notice the intra, the A right here. They're inside of the molecule or inside of the particle. Some books call them intraparticle forces because they're inside of the particle. Okay, this is in contrast to what we're going to look at in chapter 11.2, intermolecular forces, on our next page. So notice the intra, that's inside the particle where this takes place. Take a moment, make sure you got that copied down, and then we're going to go on to the next page of notes here, and we're going to focus in on the intramolecular forces right here. Not these, but once they are the particle, what makes the particle, like HCl, stick to another HCl? Or an HCl particle connects to an HH particle. So the intramolecular forces are the ones that are very, very strong. Those are the ones that are super strong compared to the particle-particle forces called intermolecular forces that are between the actual molecules. We can see a diagram right here where we can see an HCl particle right here, and we have a covalent bond right here, a polar covalent bond right here, and then another HCl with a polar covalent bond in it. But then these two would attract to one another, and this weak intermolecular attraction right here is what section 11.2 is all about. So keep these two separate in mind. Keep separate in mind that we have the intramolecular forces that are things like ionic bonds, metallic bonds, covalent bonds, and then we have the intermolecular forces, and there are three of them that we're going to look at. So the chemical bond ones are the ones that are stronger and are the intra, so maybe just write that down here, intramolecular type forces, INTRA. And then the intermolecular forces are the ones that are between molecules. So let's look at them each individually. Ionic, metallic, and covalent. These have some examples right here, and it makes their melting points and boiling points be super, super high when things are only composed of ionic bonds or only metallic bonds or only covalent bonds, because it takes a lot of energy to separate those substances. And you can see that they're on the order of 2,700 or 4,300 for their boiling point. Super, super high. Whereas things that are held together by intermolecular forces might be held together by something called dispersion forces. Dispersion forces hold nitrogen molecules to nitrogen molecules. And you can see that those would boil at 77 Kelvin. That's why liquid nitrogen is pretty cold. might be held together by dipole-dipole forces. And you can see in this one we've got dipole-dipole forces of hydrogen chloride molecules, just like we had up in this picture right here, this little red dashed line. And that, of course, has a boiling point that's much lower than something like diamond. And then the last one is called a hydrogen bonding force, and that's going to be a special type of dipole-dipole force that we talk about. And you can see that those have a little bit higher melting and a little bit higher boiling point as well, because they're a little bit stronger than the normal dipole-dipole force. Remember that these forces are between molecules, and in our next video we'll zoom in on these three types and look deeply at what causes these to hold together and what makes them be stronger or weaker based on melting and boiling points. Same thing with dipole-dipole and the special case of dipole-dipole called hydrogen bonding. So we'll focus on these types of forces now for the next couple of sections.